this afternoon we are going to start our studies of Python in earnest. By my estimate, like I said, we're going to give this thing 3 months. By the end of the 3 months, you should be a good enough Python computer programmer so that we can start the course. So if now we are doing end of March, probably by the time we are done June and you guys are supposed to be here, okay? So we can start the course like that. And by the way, the course code says it's supposed to be a second half course, but I have to start early and it has been moved to this other side, okay? So the first thing we're going to do is learn how to print numbers. My approach when it comes to teaching students how to program in Python is by doing certain tasks. I want to teach you how to print numbers. I want to teach you how to do something. I want to teach you how to do this, how to do that, how do we do this, how do we do this, how do we do that, so that by the end of the day, all these computer tasks which need to be done, if we can do them, we are able to put the pieces together in any way depending on what kind of situation we are faced with. Is that clear? So, the first thing we're going to do, learn how to do, is to print. And the first thing we're going to learn how to print are numbers. Now, it so happens that in Python, it doesn't really matter whatever it is you're printing. Whether you're printing numbers, or you're printing texts, or you're printing whatever it is you want to print. Printing is done one way, and that is by using something called the print function. Okay? There is this thing called functions in computer programming, and functions do a specific task. So in the case of when you want to print something, what we use in Python is the print function. You don't have to do anything really about this print function. You just have to use it because it already comes with Python. Are we clear? So a function like print has a name.
Yes, sir.
The name of the function in this case is this one, print. That is the name of the function, and usually when it comes to Python functions, the name of the function gives you an idea of what that function does. Like in this case, print. This thing prints stuff, okay? And what you are going to print, or what you want to print, is what you put inside here, inside these parentheses. So whatever you want to print, you put it inside those parentheses. So the print function is what we're going to use to print. Whenever you want to print something, okay, to the screen, you use the print function in Python. There is no other way of doing it in Python. If you want to print something, you do it using the print function. And how do you do that? By putting the value you want to print inside these parentheses or these brackets. For example, if you want to print the number 7, the integer 7 or the number 7, this 7, you're going to write the following. You're going to type print, then print, that is the name of the function. Here, the name of the function. Then, after the parentheses, inside those parentheses, you put in the value you want to print. Are we clear? So in this case, if I run this, it prints to the screen 7. So that's how you print a number like 7. If you want to print a number like pi 3.14, you do the same thing. Print, then you put it inside here, the value you want to print. For example, if I run that, it prints out 3.14. Is it clear what's happening?
Yes, sir. I'm able to see.
Yes. Next, you can actually have more than one print statement after the other in a cell. Okay, for example here, you can say print 100 and print that. You can put 2 print statements together. You don't have to necessarily one print here, another print there. You can have more than one print statement together like this, one after the other.
Yes.
So the first print statement is going to print out the value 100. That's why you've got 100 there, because it's printed out by the first print statement. The second print statement print is going to print out this 3.14 like that. Is that clear?
Yes, sir.
So you can put a print 100, print 3.14 after the other, one on top, the other one at the bottom. Sometimes you don't want to do that. Sometimes you want to do this. You want to put the print statements in the same line. If you want to put the print statements in the same line, like this, print 100, then print 3.14, you can do this. You have to separate your print statements with this semicolon. Okay?
Yes.
Then you do that. It prints out 100, it prints out 3.14. This same thing we have done here can be done differently also. I'll add a line of code. So I'll say print, because print can accept more than one value. 100, 7, then 3.14. So here I want to print 3 different values. I want to print 100, I want to print 7, I want to print 3.14. So I'll also add something, text, saying the print function can accept more than one value as input, as long as those values are separated from each other by commas. We can also do this. So here, no. So after this, I want to do the following. So print the numbers, print the values 100, 7 and 3.14 using one print function. So that's what we are trying to say. You are not restricted. If you want to print many values at a go, you don't need to print after print. No, you don't need to do that. You can just use one print function, then you're in business. Hope you're seeing what I'm doing and what the result is. So here, I want to print 100, I want to print 7, I want to print 3.14. When I run this is what I get. 100, 7, and 3.14. You can print multiple values using one print function. So you can see there's a difference between these and how this comes out. For this one, the 100 is on a separate line. Then after that, the 3.14 is on a separate line. Okay? You see that? Is that clear? Can you see this?
Yes, sir.
Yes, the same thing applies here. The output looks the same. The 100 is on a separate line. The 3.14 is on a separate line. So I think here you can say print the values 100. Let's just say print the values 100 and. That should be enough to prove the point, 100 and 3.14. So you can say we can print multiple values. There, 100 and 3.14. So if you say print 100, then that, so you can print as many values as you want. Okay, are we clear? about what print does?
Yes, sir.
Print is so useful that you can actually use print to print very large numbers, and it accepts values in scientific notation. Here, for example, the radius of the Earth. The radius of the Earth is this many, 6,371,000 meters. Okay? Are we clear? That's the radius of the Earth. So this large number, you can give it to the print function. Say print this 6,371,000. You print it there. So print can actually even handle very large numbers. If you want to increase the readability, okay, you can separate, as you are giving your numbers to print, you can separate your thousandths and stuff like that in groups of threes. You can separate them using an underscore, this underscore, so that it comes out like this. It looks like this, 6,371,000, stuff like that. Let's see. For you, you're doing that, but Python is going to ignore. As you can see, the result comes out the same. Here, it's fine. It accepts these spaces, but the result comes out like that. Okay, so you can see here, what you have put inside the brackets, how that number looks, and how this one looks. They look different, but they are the same number because we have just separated the 3 zeros. We have separated the other 1,000 and the million on its own by using underscores. Is that clear?
Excuse me, sir.
Yes.
What do you mean when they say underscores?
That one. Have you seen that?
Okay. Yes, sir.
Yeah. There is a dash on your keyboard. There is another one on top of the dash. That's called an underscore.
Okay.
Yes.
Okay.
Yeah. Please ask questions where you don't understand. If I mention a word which you like, what is this one? So please ask a question so that I can explain. However, we know that this 6,371,000, we can express it in scientific notation as follows: 6.317 times 10 to the power 6. This is the same number but in scientific notation. The print function accepts numbers given to it in scientific notation because we're doing physics. We're definitely going to deal with very large numbers and very small numbers like this. So the base part, this is this one, 6.317, like that. Then the 10 to the power 6 is written like this, E6. What have I done? Yeah, E6. Now the E, remember on your calculator, if you're using your calculator, at the bottom there's a letter E there. That letter E is used for engineering notation, whatever it is. Okay, it's used for expressing a number to a certain scientific notation. Have you ever seen that the letter E written in capital letters on your calculator?
Yes, sir.
Yes, I think on my Casio, it's written EXP next to the answer button. So if you write, like if I say 6, if I type on my calculator 6.317, then I press expo, then it's going to bring out E, then I put 6 there, then I can express that number. So it's the same thing here. So when you do this, then you print out, you get your number. Okay. But there is a small difference between a number which is printed out in scientific notation and a number which is not printed out in scientific notation. Have you seen the difference? There is this one here, the radius of the Earth printed out, not in scientific notation. Then there is also this one here, and the one you have printed out in scientific notation. Have you seen the difference?
Yes.
What's the difference?
There's a 0 added.
There's a
Yes,
point
sir.
and a 0 added at the end.
0.0.
Yes, 0. Okay. As much as you might not like the 0, but I can assure you, when you're trying to work with very large numbers, it is faster to write a number in scientific notation than trying to type all the digits. Are we clear? For example, the distance from the Earth to the Sun. This is the distance. So you've got the 3 zeros here, then another 3 zeros there. So you've got 3 zeros here, up to here, then up to there, then up to there. So basically the distance from the Earth to the Sun is 149.6 million meters. That's the distance. This is a very large number. You can give it to the print function like this. If you want to type out the whole number, you give it like that. Then you say print. Okay, there it comes out. Or you can put some spaces as you are typing the numbers. After the zero, after these 3 zeros, you put an underscore. Then after these 3 zeros, you put an underscore. Then after those 3 zeros, after the 600, you put an underscore like that. Try to make it clear to yourself that you're talking about 149.6 million, like that. You can also express this number in scientific notation. If you express it this number in scientific notation, this is what you get. 1.496 times 10 to the power 11. Much, much smaller. Easier to write than all these zeros. And when you give it to Python in scientific notation, like this, so you say 1.496 e to the power 11. The same number, then you run print. This is what you get. The same number, but at the cost of a dot and a 0. Are you beginning to see the advantage?
Yes, sir.
Yeah, it's faster to write a number, a big number in scientific notation, than trying to write the whole number with all the zeros it has. Things can even get worse. For example, the mass of the Earth. The mass of the Earth is 5.972 times 10 to the power 24. That is a lot of zeros, right? Like 21 zeros, I think. Yeah, 21 zeros. That's a lot of zeros. But you can save yourself the trouble of having to write such a huge monstrous number by just writing it in scientific notation. So you say print 5.972 e to the power 24. When you do that, Python now also decides to do something. It's like, okay, this number is too huge. I'm not going to write it like this. I'm also going to write it in scientific notation. So there comes a time when you are trying to print these numbers, they are very large, that Python decides, okay, this number should be expressed in scientific notation. So the print function itself, you didn't tell it anything. It decided, I'm going to express this number in scientific notation. Are we clear? Hello?
Yes, sir. We're here.
Okay, so the print function decides, depending on what number you've given it, it will decide whether to print the number like the way it is, or it will decide whether to print the number in scientific notation. It will look at whatever rules it has, then it will choose the best way to display that number. You will agree with me, 20 zeros is a lot. So it decides, say, fine, I will express this number also in scientific notation. The mass of the sun, this is the mass of the sun, 7.34767309 times 10 to the power 22. It's a big number also. So we give this number to the print function in scientific notation. When you do the print, The print function also decides, yeah, I'll express this number, I'll show this number, I'll print this number also in scientific notation. Okay, so this is the mass of the moon. Then we come to the mass of the sun, which is 1.989 times 10 to the power 30. We give this number to the print function in scientific notation, like that. Then if you do a print, the print function also agrees to say, yeah, this number should best be expressed in scientific notation.
So,
yes.
What about the plus which is in between E and 22?
Yes, the plus shows that because you can have a negative. So if you express the large, like here, the 22, so it can be 22 plus, showing you that it's positive. But if you're expressing a very large small number, it's going to be, when you express it to scientific notation, there's going to be a negative there.
Okay.
Yeah. So the print function is explicitly telling you there's a plus here. Okay? So basically that is, in the case of the mass of the sun, 1.987 times 10 to the power 23 times 10 to the power 30 plus 30. The print function also works with very small numbers. For example, this number which I have here, 0.000 something 458. If I give that number to the print function displays the same number but in scientific notation. So you can see for a very few number of zeros, the print function quickly decides to say, I'll express this number in scientific notation. Are we clear?
Yes, sir.
Yeah, that is 5.58 times 10 to the power minus 6.
To the negative.
Yes, negative 6. The same thing is here with this one here, where I have put some spaces there. And how do you put spaces? Trying to increase clarity by putting underscores there. If you give that, so there's an underscore here, there's an underscore there. If you give this number to the print function, it expresses this number like this. Same. I can also express the number in scientific notation like this. So I give it to the print function there. 4.58 times 10 to the power minus 6, that is e to the power minus 6, and when we print it, there. Okay. Next, we can print some numbers which are useful to our physics business. For example, the mass of the proton. This is the mass of the proton. There, 1.6726 219 times 10 to the power minus 27 kgs. So this number expressed in scientific notation, it's a very, very small number. Okay, I give it to the print function for printing, and the print function gives us things. So the print function can also handle very, very small numbers. Another small number is the mass of the electron, 9.1093 837.015 times 10 to the power minus 31 kgs. So I get this number, I give it to the print function here, then we print. There we have it. Do you have any questions on printing numbers? So if you have a very small number, you express it in scientific notation. If you've got a very large number, again, you express it in scientific notation. If you have got numbers in the middle, you can just type them. Yeah, as long as you don't have to type a lot of zeros. Any questions?
No questions on my part.
Mwape? You're very quiet. Are things clear on your end? I can't hear you. Okay, we're going to proceed anyway. Next, we're going to learn how to print texts. Now, a collection of characters or collection of letters, whether they are letters, characters like @ hashtag, the $sign, the %sign, all these things on your keyboard, okay? All the things you see on the keyboard, the letters or the special things on the keyboard, most of those things are characters, okay? So if you've got a bunch of these things, a collection of characters, that's what you call a string. In Python, we show that something is a string by putting it in quotation marks. Those quotation marks can be single quotation marks or they can be double quotation marks. For example, these characters, H, E, double L, O, and basically this is the word hello, okay? And we put it in quotation marks. This is what you call a string. And as you are going to see, or as it should be evident to you, if you have been very observant, if you look at our numbers, have you seen the numbers we have? Those numbers, all the numbers we've looked at? What color are they?
Yes, sir.
What color are they? The numbers we've been giving, yeah, something like green, blue, right?
Green, blue, green.
Yeah, green. Okay. So basically, Python, when we're using Python, gives colors to different pieces of information. If what you have is a number, then that number is going to be given a green color. So that if you were expecting a number, then it turns a different color, then you know something is wrong. Okay? So when it comes to these letters and characters put in quotation marks, like in this case, you can see their color is red. Whenever you put something in quotation marks, a collection of characters in quotation marks, the color is red. So this is what we call a string. Okay? A collection of characters or letters or text, basically text. In Python, text is called a string. Are we clear?
Yes.
So we have looked at a piece of information called numbers, how to express numbers, but there are also other pieces of information which your computer program might need, and that is texts. For example, maybe your name, or your surname, or which courses you take, or stuff like that. So for example here, we want to print hello. Now again, like I said, the print function does not only work with numbers, it works with a lot of things. And one of those things the print function works with is texts or strings. So for example, in this case, we say print hello. When you run that, you're going to see that hello has been printed out here. Remember what print does. Whatever you put inside here, inside the parentheses, that is what is going to be displayed. It's going to be printed out. You can also create a string using single quotation marks. So here we use double quotation marks. So if you start with a double quotation mark, you need to end with a double quotation mark. Here I use single quotation marks, hello. It's still red, so that's telling you that that's a string. Like that. Okay, so you can use double quotation marks. You start with a double, end with a double, or you start with a single, end with a single. If you try to mix them up, you start with a single, then you try to end with a double, like in this case here. I start with a single quotation mark, I end with a double quotation mark. If I try to do this, then Python is going to protest, and it's going to tell you, it's going to scribble out things here, saying there's a problem, and it's going to scream at you saying there's something called a syntax error. Okay. Now, syntax is how a language is used, or how a language is constructed. So here, Python is simply saying and underlining this whole thing, say this thing, there's something wrong with this. It's not following the rules. Because the rules are, if you're creating a text or a string, if you start with a single quotation mark, you need to end with a single quotation mark. If you start with a double quotation mark, again here, if you start with a double quotation mark, you need to end with a double quotation mark. But as you can see here, I start with a double quotation mark, I end with a single quotation mark. If I run this, again, Python protests, say this whole thing is wrong. Okay? The one thing you should be aware of is that Python would not let you get away with errors. If there's an error, Python is going to point it out and tell you this thing is not correct. Is that clear? And you need to fix that. And you need to fix that. So if there's an error, you need to fix that. In our case here, I'm not fixing these errors because I'm using these errors for teaching, trying to show you what happens if you mix up the quotation marks. If you start with a single quotation mark, then you're trying to end with a double quotation mark, or if you start with a double quotation mark, then you're trying to end with a single quotation mark. You're going to land in problems. Okay? Are we clear?
Yes, sir. Clear.
Yes. The next thing is, as you can see, our string hello is just one word. Okay? But you can actually have a string which is made up of many words. You can actually have a string which is made up of many words. You can print a string which is made up of many words. For example, this one. I can even add something here. And yeah, an exclamation mark at the end there. Here. Like that. So I have got hello, then there's a space, word, then there's an exclamation mark. So everything inside here, everything inside the quotation mark, these two quotation marks, is considered to be a character. There is the letters, the HELLO. There is also the space between the word, the two words. Even the space, the one highlighted there, that is also a character. Okay. There is also the exclamation mark at the end. That is also a character. So if we do that, this is what Python prints out. It says hello world with an exclamation mark. The same thing can be done here. So you can actually come up with strings which are very long, or whether you want your string to be a paragraph or a sentence, it's up to you what you want. As long as those things are in quotation marks, double quotation marks, or they are in single quotation marks. You start with a single quotation mark, you end with a single quotation mark. You start with a double quotation mark, you end with a double quotation mark. Is that clear? So two things we have looked at. We have looked at how to print numbers. We have also looked at how to print strings or how to print texts. These are skills you're going to need. Are we clear?
Yes.
The other thing you can do with Python, which is why we need it, we are trying to learn about it, is that you can actually use Python as a calculator. Okay. For example, you can use Python to add two numbers. Two numbers, you can add them. And if you want to add numbers, you use this plus operator. You use the plus sign on your keyboard, the plus. So when you say print 7 plus 9, this is not going to print out 7 plus 9. It's going to print out the sum of 7 plus 9. Okay. So Python is going to add 7 to 9, then it's going to print out 16. Have you seen that?
Yes, sir.
Yeah, it doesn't print the 7, it doesn't print the 9, it adds 7 and 9, then it gives you 16. You can even put some spaces between the 7 and the plus in order to increase what is known as readability. Now, these things you can't see, like spaces, these are what are called white spaces in programming or in computer language. Okay, a white space, when Python finds a space like this, the one I've put there, after the 7 and the plus, then before after the plus, before the 9, those two spaces, Python is not going to print out those spaces. It's going to ignore them because it doesn't need them. So we still get 16. If I add more spaces here, there's a space, then after the 7, another space, then after the 7, after the plus sign, a space, then after the 9, a space, the answer still stays the same. I can even put a space here, then another space there, then another space there, another space there, and the space here, and the space there. The answer stays the same. These spaces I'm putting are being ignored. The spaces are only there to make your Python code more readable. Okay, it's for us humans who are going to look at what you have done, so that we don't have difficulty trying to say, hey, what was this person typing? Are we clear?
Yes, sir.
Yeah, so you can add numbers by using the plus, and any spaces you put are going to be ignored. If you can add numbers, you can also subtract numbers by using the minus sign or the dash. So in this case, you can say, for example, 20 minus 8. Let me do this. 20 minus 8. You get 12. Then I say, I do 8 minus 20. You get minus 12. So you see, Python is aware of this whole idea of, say, if you subtract a small number from a large number, you get a positive number. If you subtract a large number from a small number, you get a negative number. It's aware of that. The print function is doing all this. And Python is aware of this. So you can add numbers using the plus. You can subtract numbers using the minus. You can also multiply numbers using the asterisk or the star. The star is called an asterisk. This. It's called an asterisk. So you can use that to multiply numbers. For example, you can multiply 20 times 8. When you multiply 20 times 8, you get 160. Or you can multiply 8 times 20. If you change them, the answer, according to us humans, should be the same. What does the computer think? The answer is the same. Is that clear?
Yes.
You can also, you're not restricted to only multiplying two numbers. You can multiply as many numbers as you want. Like in this case, you're multiplying 2 times 3 times 5. Then you also multiply 3 times 2 times 5. Any numbers, any set of numbers, you can multiply them in whichever way you so desire. That's up to you. You are the programmer, so you can multiply your numbers whichever way. Excuse me. And in this case, you can see the answer is 30, 30, 30, 30, 30, because we're multiplying the same three numbers, but we're just multiplying them in different ways. That's what you expect. Because 2 times 3 times 5, 2 times 3 is 6, 6 times 5 is 30, 3 times 2 is 6, then 6 times 5 is 30, 2 times 5, that's 10, 10 times 3 is 30, 5 times 2, again that's 10, then 10 times 3 is 30, 5 times 3, that's 15, 15 times 2 is 30. So you can multiply your number. There is no special way order in which you can multiply your numbers in any way you like. The answer, Python is going to figure out, say the answer is this. Is that clear?
Yes, sir.
The other thing which you can do is division. You can divide your numbers. For you to divide your numbers, you use the forward slash. This slash. When you're dividing your numbers, you use that slash. So in the first case, we are doing 20 divided by 5. Then next you're doing 5 divided by 20. Then negative 20 divided by 4. Then negative 18 divided by negative 6. What are the answers? For the first one, 20 divided by 5 is 4.0. You yourself, if you just say 20 divided by 5, you're going to say 4. But Python, when it's doing division, it always assumes there's going to be some dot or something which is going to be there. So you get 4.0. This one, 5 divided by 20, you get 0.25. This one, minus 20 divided by 4, you get minus 5.0. This other one, minus 18 divided by 6, you get 3.0. So Python can actually divide. can divide numbers. Okay? Are we clear?
Yes, sir. Clear. Very clear.
Sometimes you can try to carry out a different sort of a division. There is the normal division, like the one we do. For example, I'll do it here. The one using the one slash. You're just using one slash, for example. So here, 20 divided by 7. The answer is 2.85. This is a very, very long number. But if you don't want this decimal part, everything after the decimal point, after the point and everything else after that, you can carry out something called integer division. Integer division is carried out using 2 backslashes. Okay? Are we clear? You carry out integer division using 2 backslashes, and if you run this, print 20 2/7, what you're going to get is just 2. It doesn't even round off, it just gets everything, the decimal point and everything else, it chops it off and throws it away. So you just get 2. So if you're doing some kind of division where you're only interested in the whole number, then this is what you're going to do. Are we clear?
Yes.
All right. Next, some other thing you would want to do is you would want to raise a number to a power. For example, 2 to the power 3. The business of raising a number to a power is done using these 2 asterisks. So if you put your multiplication symbols, the 2 of them next to each other, then they are now used for a different purpose. For raising a number to a power. For example, print out 2 raised to the power 3. How do we write that? We write like this. 2 raised to the power 3. 2 to the power 3. That's how we write it. 2 to the power 3. You get 8. Is that clear?
Sir, repeat
Yes.
that point again for the 2 double stars.
The double stars are used for raising a number to a power.
Okay.
Yeah, for example, like here, 2 to the power 3. If you want to raise a number to a power like this, you see that?
Yes, sir.
Yes, this is what you're going to do. So you're going to put 2, then after the 2 double stars, telling Python, raise this number, raise the number to the left to the power 3.
Okay.
Yeah.
Understood.
Then you get 8. Then here, 5 raised to the power 2. I'll do an edit here. 5 raised to the power 2. 5 raised to the power 2. There, 5 raised to the power 2 is 25. You see? 5 raised to the power 2 is 25. You can also actually raise a number to the power of a small number, a fraction, or a decimal number. Like, for example, 25 raised to the power 0.5. 25 raised to the power 0.5. There, 25 to the power 0.5. 25 to the power 0.5. This is just the square root of 25. You get 5. Are we clear?
Yes, sir. What
So
get
you
here.
can do addition with a plus sign. You can do subtraction with a minus sign. You can do multiplication with the asterisk. You can do division with the forward slash. You can do integer division with the 2 double forward slashes. You can actually raise numbers to a power using these 2 asterisks. Then last but not the least, you can also actually try to find the remainder of a division. You can divide two numbers. Then if you're not interested in what the whole number is, but you're only interested in the remainder, we can also give you the remainder. The remainder is obtained by using the percent sign. This percent sign is pronounced as modulus. So here we say print out the remainder of 20 divided by 7. Remember what we had for 20 divided by 7? When it divided 20 by 7 normally, up here, we got some very, very large number here. 20 divided by 7 was 2.
Yes.
Then point this whole thing in that number. Okay? So if you are interested only in this bit, how much is this bit? Okay? So you have seen what to do if you're only interested in the 2. If you're interested in only the 2, then you carry out integer division. Use 2 forward slashes. But if you're only interested in what comes after the point, the number, what's the remainder, then you use the percent sign. You say print 20% 7. So what is the remainder of dividing 20 by 7? So in this case, what you get is 6. 7 goes twice in 20, and 2 times 7 is 14. 14 minus 20 is 6. So you get your 6. Is that clear?
Yes.
You can also get the remainder of dividing. For example, if you divide 10 divided by 30, you want the remainder of 10 divided by 3. So the remainder of 10 divided by 3 in this case is just 1, because 3 goes into 10 3 times, then the remainder of 1. However, it is usually not very useful to try to get the remainder of dividing a small number by a large number. For example here, 3. What's the remainder of dividing 3 by 10? This is not very useful, because the remainder is always the number in front of this. You can see it's 3. If you try the same thing for 6, what's the remainder of dividing 6 by 20? 20 goes into 6 0 times, the remainder is 6. So it's always the number in front. So we don't do remainder things for very small numbers. We want to find the remainder when you're dividing very large numbers. Are we clear?
That's the question.
Yes. Mape, yes. Go ahead, please.
What of when subtracting, you put instead of just 1 minus, you put a double minus? Like,
No. A double minus, I think, is going to become an addition. Normally, a double minus is addition in real life, right? Yeah. So if you do that,
all right.
yeah, we can try it. I think we can try it. There's nothing wrong to be afraid
Let's
of.
try.
Yeah, we can try it. So we're saying print 3 minus, let's say 5. And what do we get? Or a double minus. You want it like this, or I don't know. First, we'll put some space. Let's see what we get. Okay, this gives us 8. If we add another space, we do this. Print 3 minus 5. What do we get? Yeah, we still get 8.
Again.
Yeah. So basically, the
Yeah.
minuses are added, they're multiplied with each other, they become positive. Is that clear?
Yes, sir.
Alright, so I'm going to delete this. Do not be afraid when you open your Google Colab, okay? do not be afraid to try out things which you're thinking, what if this, what if this? That's how you learn the most. What things you can do, what things you can get away with, and what things you're not going to be allowed to get away with, okay? We also use parentheses when you're doing calculations, okay? You can also use parentheses in order to tell Python how you want numbers to be added or subtracted or multiplied or divided. So when you use parentheses brackets, you are telling Python, do the stuff in the brackets first. Okay? Are we clear? When you put brackets, you're telling Python, I want you to do the stuff in the brackets first. So in this case, here we do not add any brackets or parentheses. So there is 1 plus 2 times 3. So we give this to Python. Python looks at this, then it says, okay, the answer is 7. So you ask yourself, how did Python do this? Clearly, if it starts out by doing the addition, 1 plus 2, that's going to be 3, then 3 times 3, that's going to be 9. So Python didn't do that. It started with a multiplication.
Multiplication.
Yes, 2 times 3, that's 6. 6 plus 1, 1 plus 6, that's 7. So there is a way in which Python does calculations, especially when you combine addition and subtraction and stuff like that. There is a way in which these things are done. Okay? But if what you want to do is you want to tell Python, no, I'm not happy with what you've done. Yes, I know it's 7, but I want you to start by adding 1 plus 2 so that we have 3. Then after adding 1 plus 2 so that we have 3, then you multiply that by 3 so that you've got 9. You can tell Python by putting the things you want to be, the calculation you want to be done first, you put it in parentheses, in these parentheses, like the way we have done it here. Is that clear? So this way, 1 plus 2 is going to be added first. We're going to get 3. Then the 3 is going to be multiplied by 3. So we're going to get 9. You see? We get 9. Is this clear?
Yes.
So we have changed the way in which Python actually does something. Okay, the order in which these things are done has been changed. Okay, normally Python would start by doing the multiplication, then after the multiplication is done, it would go to the addition. But this time we have forced Python saying, no, we don't want you to start with the multiplication, we want you to start with the division, with the addition. So you put your calculations you want to be done first, you put them in brackets, then that. Okay, we can also do the following here, this side. We can put the 2 times 3 in brackets. The problem is when you put the 2 times 3 in brackets, the answer doesn't change. The answer is still 7. Okay, but what has changed? If you look at this, print, you look at this, the answer is 7. You also look at this, the answer is 7. What is the difference here? Which one is easy to read? Which line is easy to see what's going on? Which one is easy? There is line 50, there is line 48.
Line 50.
Yes, line 50 is easy because line 50, as much as the parentheses are not changing anything, they show us quickly what is being added first. Okay?
Yes, sir.
Yeah, in line 50, you quickly see what's being added first. So, the multiplication is being done first, then after that, the addition. So sometimes, as much as things might not change, but sometimes you want to, it's very important that you do this. You improve the readability of your Python code. And so far, we have looked at 2 ways of doing this. You can improve readability by adding spaces. Remember? The first thing is by adding a space. There is this, how this looks, and this. They're same thing, but this one is better. Okay, we can add a space by adding some spaces where you think it's appropriate, and also by adding parentheses. Are we clear? The result did not change. When you added a space, the result didn't change. Here we have added a bracket, parentheses, the result hasn't changed. It's still 7 and 7. So you can add a space, you can also add parentheses without actually changing the final result of a calculation. But when you add these spaces and you add these parentheses, it is easy to read what's going on. Your code is more readable. Yeah, the computer doesn't have a problem with it. It is us humans who have to look at what you have written who might have a problem. Are we clear?
Yes, sir.
Okay, Mape? Are we good? We have done 1 hour. Do people need a break or we continue?
Continue.
Okay, the next thing we are going to talk about is something called comments. Okay? Comments are very, very important in Python, in programming, because when you add a comment, you are actually adding notes to yourself to explain what a line of code is doing. Okay? You are adding notes to explain what the line of code is doing to yourself, or maybe when you write this computer program, you are going to send it to someone else. That someone else you're sending this computer program to might not be so good at Python as you are, or they might be good at Python, but it's always nice to see comments, okay? So that you can clearly see, oh, so this is what's happening here, and that's what's happening here. The other thing, is how do you make a comment? How do you start adding a comment to your code? Well, you start adding a comment by using a hash, this thing called the hashtag, okay? By using a hash sign or a pound. So you start with a pound, then everything else you're going to write after this comment, after the pound, is going to be ignored by Python. Python is not going to treat it as text or as some number, it's just going to ignore it. For example, here, I add a hash, okay? Then everything, the hash itself is green, a type of green. Then everything else after the hash, as you can see, is green. So this tells Python that this is the comment. If I run this, Python doesn't do anything. It just says, okay, fine, I have to run something, then, oh, I found a comment, then it doesn't do anything, okay? The other thing is, where do you place comments? Usually, it's better to place comments before your code or on the side of your code, like this. Before your code runs, you can put a comment like this, and this says this is a good comment, then print 3 plus 7. So the comment itself is going to be ignored. It's not going to be run. The only thing which is going to be run is the 3 plus 7. It prints out 10. The comment itself is ignored. Okay? Are we clear? But you're adding notes to yourself so that you can try to explain to yourself, oh, this is what I'm trying to do. Are we clear?
Yes.
Yes, it's important that these things be added in your Python code. Also here, you can also add a comment after the code. Like here, print 3 plus 7, then after you can add a comment. This is also a good comment. Besides, like that, 10. So you can see the code runs, it prints out 10, but the comment stuff is ignored. But it's there. It's there to remind you or to tell you, okay, this is what's happening. If you put the comment before the code, you start with the comment, then when you're done with your comment, you put your code like this. You see what happens to your code? You print 3 plus 7. It also turns green. And if you run this, nothing happens because your code has been commented out. Is that clear? Are we clear on comments?
Yes, sir.
Yeah, so this is a bad comment because this comment is going to prevent this print thing from running. Okay, if you press enter, then you do this, the print runs. Okay, but if the print and the comment are in the same line, nothing runs. 0. There, 0, nothing happens. This one, putting comments after things have happened, after code has run, this does not produce an error. Okay, yeah, it runs the code, it doesn't produce an error, but this is misleading. Okay, because what in computer thing programming, what people are used to is you put the comment before the code runs or on the side of the comment. Putting comments after is kind of considered to be misleading. Okay, so that's about comments. Do you have any questions? You can add as many comments as you want. You can add as many lines of comments as you want. The only thing is Python is going to ignore them. It's like you're talking to someone who talks a lot, huh? Then they talk. Then at the end of the day, you ask them, have you finished talking? Then they're like, you're not listening, because you just ignored them. Okay, so you can add as many comments as you like. Python is not going to tell you you have committed an error or something like that. It's just going to ignore them. Are we clear?
Yes, sir.
The next thing we want to talk about, which we want to bring to your attention, is something called a variable. There are variables in mathematics, yes, but there are also variables in computer programming and computer science. Now, a variable is a word you use for storing values, and those values can be numbers, or they can be words, they can be letters and stuff like that. This is a word you're going to create, and in this word you're going to be storing values. So instead of printing those actual values, you'll just be printing those words. Are we clear? That's what a variable is. It's very, very important. It's very important for computer programming that you have variables. For example, I create a word called PI, pronounced pi, and this word pi, I give it a value 3.1459268. So this value of pi, by doing this, I have an equal sign here. You've seen the equal sign? So on one side of the equal sign, on the left side of the equal sign, I have the word pi. On the right side of the equal sign, I have the value. So what's going to happen here is that the value which is on the right hand side of the equal sign is going to be stored in this word pi. And when I do this, okay, Python doesn't complain. It agrees with whatever is happening. Now, when I print out the word pi, the variable pi, when I print out the variable pi, I don't get pi, but what I get is the value stored in pi. You see this?
Yes.
This is what a variable is. A variable is a container for values. Those values can be numbers, or they can be they can be letters, words, and we have looked at some big numbers like the radius of the sun, or the distance to the sun, the mass of the sun, some small numbers, the mass of the electron. All those you can store them in variables, okay, so that you can easily use them, because you don't want to be printing such large numbers, typing such large numbers over and over and over again. You're just going to make a mistake. Okay, if you try to print a variable you have not given a value, like in this case here, this variable pi has been given this value. Then here I try to print a variable radius which I have not given a value. Okay, if I try to do this, I say print radius. If I try to do something like this, Python is going to protest. Then it's going to say there's something wrong. This is wrong. And it's going to spit out something, say there's something called a name error. And what does a name error involve? Python is going to say name radius is not defined. What this means is that this variable radius has not been given a value. So in Python, you are not allowed, from the word go, you are not allowed to use variables you have not given values to. You're not allowed to print them. You're not allowed to use them in calculations. You're not allowed to do anything with them. If you have not given them values, Python is not going to allow that. Are we clear?
Yes, sir.
All variables need to be given values. So we do what needs to be done. We have an equal sign here. On the left hand side is the variable we want to store the value in. The name of the variable is radius, and the value we are storing in this variable is 10. The other thing I want to point out about variables is the name of your variable should tell the person, you or whoever is using your computer program, what it should give them an idea of what kind of value is stored in that variable. For example, if I create a variable pi, then I store in this variable pi the value 10. Pi and 10 are not the same thing. This variable is called pi, but how come there's a value 10? Python is not going to refuse, but it's up to you, who is doing the programming, to make sure that your variables contain the right values. Are we clear? Are we clear on this? You need to make sure that your variables, the name of your variable, and the value which is being stored in that variable, they seem to match. Python will not know if you, in radius, you put pi. It won't know. Okay, so here we create a variable radius, we've given the value of pi, 10. Then now when you print it, there's no problem. Now Python prints out radius and it tells you, oh, radius, I looked at this variable radius, inside it's got a value 10. Is this clear on what variables do and how you store information in variables?
So,
Yes.
so like creating a variable, it's up to us to put the number. For instance, here radius, we have to put 10 before we print the radius.
Yes,
That's
yes,
when-
yes, 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 yes,
that's
yes.
the correct answer.
Yes, you have to put the value there before you print it, otherwise you give you an error.
Okay.
Yes. So, now this is good. We have a variable pi, which has got the value for pi. We have got the variable radius, which has got the radius of a circle. We can actually use these variables, pi and radius, we can use them to do a calculation. For example, we can work out the area of the circle. And how do we do that? By multiplying pi times the radius squared. Because the area of a circle is pi r squared. Right? The area of a circle is pi r squared.
Yes.
A There. The area of a circle is pi r squared. So we can actually do this. So we print out pi, the value for pi, times the radius squared. If we do this, we get the area of our circle. So once you create variables, these variables can be used in calculations. For example, in this case, where we're working out the area. Okay. The good thing about variables is once you can change the value in a variable. Okay? Once you store a value in a variable, that value has not been written to stone. It can be changed. For example, our radius was 10 here. We change our radius now. We're like, okay, now we want the radius to be 5.5. So we change it. Put radius this side. So the equal sign on this other side, you put radius. Then this side, you put the value you want to store now in radius. So the value which was there before is going to be removed. It's going to be erased. Then you're going to have a new value stored there, 5.5. Okay, then if you print the radius now the radius is 5.5. It's no longer 10. That's a good thing with variables. Their value can change depending on what you need at that particular point. So you can change the value of the radius. Then you can use this changed radius to work out a new area. Pi times radius squared. You work out the new area. There, that's our new area. Are we clear? Is it clear? Hello? Rodan, Chuck, and Mape. Is it clear what we're talking about?
Yes, sir.
Okay. Now, remember, look at this. We have worked so far. We have worked out the radius, the new area here. We have also worked out the odd radius, the odd area here. Actually, what we can also do is we can even do further with variables. We can store the result of this calculation. This pi times radius squared, we can store it another variable. We can store the result in another variable called area. We know we're just from multiplying pi times radius to the power 2, so that we know the answer is this. Okay, we can actually store this pi times the radius squared. The result of this thing can be stored in a variable called area. A variable called area. So let's do that. When it's done, then we're going to print out area. Okay, that's finished. Then we'll print out the area. There. You see? So when you do calculations, the result of a calculation, you're doing calculations with variables. The result of those calculations are doing with variables. You can actually also save them in another variable and you can print it later on. Area. Again, the name of the variable should match the information which is being stored in the variable. Very, very important. Okay? So you can't be using variables like X, Y, I, B, A. No. You need to choose a proper name for a variable in Python so that we know exactly what's going on and what it is you're doing. I have looked for proper variable names. I've looked for area. I've looked for pi. I've looked for radius. These are proper variable names. And these are things that got uses. We use them in physics and in mathematics. Okay. Now, variables are not restricted to only storing numbers. So far, pi stored a number. Radius was a number. Area is a number. You are not restricted to storing only numbers. And the other thing is, you are not restricted to only using one word variables like pi. This is just one word. Pi is one word. Radius is one word. Area is one word. You are not restricted to that. If you need to create a variable which uses two words, for example, this one, first name, then the two words have to be connected to each other using what is called an underscore there. Okay? The reason is because we want to have we want to have proper variable names. Okay? We want proper variable names. So in this case, first name. First is a word, name is another word, so we connect them. First name, so we connect them using an underscore. This is a proper variable name, first name. Then, as usual, the name of the variable is on the left side of the equal sign. Then the value you want to store in the variable is on the right. So this time around, we want to store the name Mike in the variable first name. Like that. Then we print out the variable first name. So we get Mike. I also create another variable surname. Okay. Then in this surname, I want to store the name price. Like that. Then I print out surname price. I can also create a variable called age. I'll be turning 35 very soon, next week. So here is a good variable name, age. And how old am I going to be turning? 35. And maybe you want to explain to someone, say, no, this is not 35 months or something like that. It's 35 years. You add a comment at the end here. So you can use a comment for this. You can use a comment to add units, to tell the person who is doing whatever it is, say, no, this thing is in this units. So in this case, age in units of years. Okay, like that. So you have to choose nice variable names. Then you print out the age. $35. Remember, like I said, it's possible for you to create what are called multi-word variables as long as you connect the words with an underscore. For example, this one, electron mass. So you want to create the variable electron mass, so you start with electron, then the mass, you connect electron and mass, you connect them using an underscore. So this becomes the variable name electron mass. Then the value you want to give electron mass, this is the value. Now, previously we looked at electron mass, but we did not even know what the units are. Now you can even add the units. Say, okay, fine. This electron mass, this is a comment because it starts with a hash. In kgs, electron mass in kgs. So that's another use for comments. Adding units. You're trying to explain that this particular quantity has got this many units, is in this units. Then if you print out electron mass, this is what you get. 9.10938.356 times 10 to the power 31. Is that clear?
Yes, sir.
Okay, so that's how you create nice variables. It's very, very important that you are able to create nice variables which store things. And sometimes it will be very, especially in your physics course, it will be very important that you also explain to us sometimes what the units are going to be, like I've done here. Electron mass in kgs, or my age in years, like that. You could add a small comment to explain what units are being used. We have looked at numbers. We have looked at words and variables. There is another type of value which you are going to meet in your Python journey. And these are what are called Booleans. Now, Booleans are just true or false answers, values. Python accepts a true as a value, it also accepts a false as a value. Now this true has to be written properly. It has to be written like this: capital T, then the rest are small letters, and capital F, then the rest are that. So these are values, true or false values. And you know that computers use these ones and zeros to represent true or false states. And yeah, Python, people who made Python decided, okay, yeah, we should also be able to do true or false stuff. Is that clear? So here I create a variable called answer. Then the value I want to store in this variable is true. So I do that. Then I print answer. Then it shows me true. Here I change the value which I'm storing in answer. Since it's a variable, so I can change the values I put there to false. Then I print answer. I get false like that. So you are going to meet these true false values. We call them Booleans. They are there in Python. We use them for all sorts of things. The next bit is something called data types. Now these data type things, some of these things I've already met. Actually, the basic ones we have met. For example, an integer. An integer is a number which does not have a decimal point. Remember, we printed 7. We said print 7, print 100. Those are integers we're printing. Then a float. A float is a number with a decimal point. For example, pi, 3.14, or the whole value of pi we printed out. Then there was also an integer, my age, 35. 35 did not have a decimal point. So a number which does not have a decimal point, that's called an integer. A number which has got decimal points, that's called a float. Then if you are talking about words and letters, that's what you call strings. Then these true or false values, these are called Booleans. Okay? Why are we talking about this? Because sometimes your variable can have an integer, it can have a float, it can have a string, or it can have a Boolean. You don't know. Okay? Yes. The name of the variable should give you an idea what your variable, what kind of information your variable has. Okay? The name of the variable should give you an idea of what kind of information your variable has. Sometimes that's not quite correct, or it can be misleading, because you can have a variable like pi and somebody stores a value of 10 in there. Python will not know. So sometimes it's necessary to check, it's very necessary to check what kind of value is contained in a variable. It is necessary to check what kind of value is contained in a variable. And how do we do that? For us to check the kind of value which is in a variable, we use a function called type. This function called type, you're going to give it the name of the variable, then it's going to look inside this variable, then it's going to tell you this variable contains this kind of data. For example, pi, right now, say type, then pi. So it looks into the variable pi, then it tells us, oh, pi contains a float. A float is a number with a decimal point. Then we give the type function, we give it first name. First name is a variable you have created. So type is going to look at first name and it's going to tell us, oh, yeah, this, I've looked at this guy first name, it's a string. We give type age, the variable age. It looks at age and it tells you, oh, I've looked at age, and age is an integer. So it expresses these things: float, string, this is str for string, then this is int for integer, then the other one, answer, you give it answer, it says, okay, I've looked at answer and it contains this, a bool. A bool is short for a boolean. Is that clear? This is how we check. This is how you check in Python what kind of value is in a particular variable by giving the variable name to this type function. This type function is going to tell you, oh, this guy has got this type of value, this type of value, this type of value, and like that. Any questions? We are slowly building on what we have learned and going forward. Slowly increasing our knowledge. Remember I said my way of teaching computer programming is by how do you do this, how do you do that. So once you learn how to do a certain thing, that's good, then we build on that, then we move forward. Okay. The other thing I want us to talk about is something called string concatenation. String concatenation is basically adding strings. We have seen how to add numbers using the plus sign, but you can also use the plus to add words or strings. When you use the plus to add words or text, that process is what is called string concatenation. For example, I want to add the word hello and world. So I'm going to say print hello, then plus the other word world. When I do this is what I get. I get hello world without any space. So I have added a word with another word. This is what is called string concatenation. So you can do this. Okay? Or I add a space at the end here of world, of hello. I add a small space there. Then I add with world. When I do that, then the output looks like this. It looks like hello world, like something nice. Or you can add a space at the beginning of world. Then you add them, hello world. Usually these two ways, this what you have done here and what you have done here, this we don't encourage. What we encourage is the following. Hello, when it's on, plus you add a space on its own, then plus world. This is the best way of adding things. The space is also a string. Is that clear? The space is also a string because the space is inside two quotation marks. So you say hello, then plus a space, then plus world. When you do this, we get the following result. Hello world. Is that clear? On how you add strings or how you add text?
Yes, sir.
Remember also that we are making a video of this thing. So the video is going to be uploaded to YouTube. Then the link to the video, we're going to put it in Moodle. These same notes, because these are the ones we are going through today and we're making changes, the actual notebook is going to be the link to the notebook. We're going to put it in Moodle. Then when you click on it, it's going to take you to somewhere where you can open the notebook with with the Google Colab. Okay. Remember we created a couple of variables. First name, print first name, that's Mike. Then the surname was Price. We can actually print the two of them by adding them. First name, then plus a space, surname. We want to print Mike Price. So we want to print the two of them at once as one word, as a full name. So first name, Mike, then plus, we'll add a space, then surname at the end, Price. So when you do that, this is going to come out as Mike Price, like this. This thing we have done here, this Mike Price, we can actually store this Mike Price from these two variables. We can store it in another variable, and that other variable, we're going to call it a full name. So we're going to say full name as a variable, then my first name plus space plus surname. So whatever this is, which you have seen, which is this Mike price, this value is going to be stored in this variable full name. Then when you print out full name, we should get Mike price. Okay. Then you can do the following. My name is, so you can print out, my name is Mike Price. Then with a full stop. My name is Mike Price with a full stop, like this. My name is Mike Price. So there is this, my name, then you put a plus, the Mike Price and full stop. The other way to do this is if you remember that, oh, this is a value, then this is a value, then this is a value. So you can use print in a clever way. You can say print, you can do this, my name is as a value, your first string, then comma, then your second string is going to be the full name. If you can do this, then you put a comma, then at the end the last string is this. If you do this, the result should be the same, and you run it. We are using the fact that print can accept multiple values. Remember when you printed 10, 100 and 3.14 in one line? This is the same thing, except the difference here is where the full stop is, there. But without doing any fancy addition plus, here we use two pluses. Here we do concatenation. We add plus, we add my name is, then plus full name plus dot. Here we just say my name, then put a comma, full name, put a comma, then the result is the same. Almost the same, not exactly the same because of where this dot is and there, but kind of the same. Is that clear?
Yes, sir.
Okay. Sometimes you want to change data. You want to change data from one type to another type. Okay? When you change data, for example, you have a number which is a 7, then you want to add a dot there so that it becomes 7.0. So what you have done there, you have a 7 which is an integer, then you add a dot, it becomes 7.0. You have changed the integer into a float. When you do this, changing of data from one type to another, this is what is called data type conversion or something called casting. Okay? For example, here, you're trying to add 1 plus 2. 1 plus 2 is 3, right? But if you try to add the number 1 in quotation marks plus 2, this one is no longer the same as this, because this one here is green, the other one we have here is red. So they are not the same thing. Is that clear? If you have a number, then you put it in quotation marks, that number stops being a normal number. Okay, it becomes a string. Strings are red. Are we clear? That's where the color coding comes in. Numbers are green. Words, strings are red. If you try to add a string with a number like this, you are going to land in problems. Python is going to come screaming at you saying, no. How do you add a string to a number? You are not allowed to do that. You can only add Here it says can only, and it tells you what kind of error you have committed, offense you have committed. It cites you an offense, something called a type error. And under these circumstances, the rules say that you can only concatenate a string to a string and not to an integer. So this addition of strings, the rules are that you can only add a string to another string. You cannot add a string to an integer. Are we clear?
Yes, sir.
Yeah, so there are rules to this addition business. There are some rules which have to be followed. Okay. Here, if you're trying to add 1 plus 2, 1 is a number, it's green. The 2 is not a number, it's red. It's a string. If you try to do this, again, Python will come screaming at you saying, no, not allowed. This kind of thing is not allowed. Again, it screams at you, says you have committed a type error, and it tries to explain to you what kind of offense you have committed. Are we clear?
Yes, sir.
So the point I'm trying to show here is Python will try to help you as much as it can by being harsh. If you make a mistake, it will scream at you, say, this is a mistake. This is how you're supposed to do it. It will try to offer an explanation. Hopefully, you will know enough Python so that you can understand what it's trying to tell you. Okay? It's like you, some English tutor, you're trying to learn how to speak English. Whenever you commit a mistake, says, no, this is a mistake, then please try to do it this way. So don't take this as a, what's this, too harshly. The computer is trying to help you. Python is trying to help you so that you can speak to your computer in a more proper way. So if you want to add numbers as strings, basically you need to do this. Both numbers, you need to change them into strings by putting your numbers in quotation marks. Once you do that, what you are going to get is not, when you add 1 plus 2 in strings, quotation marks, what you are going to get is not 3 anymore. What you are going to get is 12. This is not 12, the number. This is strings being added to each other. Is that clear?
So I didn't get you there.
Here, these are not numbers. This 1 in quotation marks and this 2 in quotation marks, these are not numbers. These are strings.
Become a string.
Yes, these are strings. And strings, as you have seen, they are added like what? Remember what you did earlier? Hello world, like this?
The hello.
Hello and world. This is how they're added. So what we have, as long as it's red, whether it looks like a number, but it is in quotation marks and it's red, it is a string. So instead of getting your 3, which you expect, what you get is 1 and 2. You get this? 1 put together with 2. They are not actually added by the addition you expect. Because they have become strings, or they are now text. Is that clear?
Yes, sir, it's clear.
Yeah. Now, apart from just putting your numbers in quotation marks, if you don't want to, because Python does not allow you to add numbers and strings together without doing anything, the only way you're allowed to add numbers and strings together is if the numbers are in quotation marks. Okay? So what are you going to do? If you still want to add this guy, this one, there's something you can use. Python gives you access to a function called str, short for string. This function str changes your number into a string. Okay, so basically this function str, when you give a number to this str function, this str function is going to put quotation marks on that number so that that number becomes a string, so that you can add this 1 plus this. When you do that, you get your 12. Okay, the reason why this happens is because this 2, when you give the 2 to str, the string function puts some quotation marks on the 2 so that it becomes like this. Are we clear? Hello?
Yes, our clear.
Yeah, so the string function, this str converts a number you have given it into a string.
Yes, we are clear.
Converts the number into a string. That's what str does. So whenever you need to change a number quickly into a string, just give it to str. Here also we convert the 1 into a string. So we end up with 12. Here, convert the 1 into a string, end up with 12. Then there, we can convert both numbers 1 and 2 into strings. Then we add them, we still end up with 12. Then here, I can convert my edge. That's my edge. That's my edge. Then I can check the type. What kind of thing is my edge? That it's an integer. Then here I try to do the normal addition thing where I'm adding string concatenation, where I'm adding strings, then things. This is a string, as you can see, plus full name. Full name contains Mike Price, that's a string. Then I put a dot, that's a string. I am, that's a string. Then the age is an integer. Then this is a string. So basically what I'm trying to do here, I am trying to add strings and a variable which contains a number. If you add strings and numbers, you get an error. If you add strings and a variable which contains a number, you get an error. This is going to give me an error. There, comes screaming, say there's something wrong here. And it tells you where is the error. What kind of error is it? It tells you type error, can only concatenate strings to strings. The problem is this age. The age is a problem because age is a number. So what I'm going to do is, I'm going to convert the age into a string by giving age to the function str. So str is going to look at the variable age, then it's going to find the number there, then it's going to get this number, it's going to put quotation marks on it. When it puts quotation marks on it, then the age is going to turn into a number. Then I'm going to say, oh, my name is Mike Price, I am 35 years old. So you can create a nice sentence like that by adding strings and numbers and changing some numbers into strings. And how do you change a number into a string? By using the str function. Are we clear? So here, if you want to change a number into a string, you use the str function. Is that clear?
Yes, sir.
That's not the only thing you can do. You can actually change strings into numbers also. For example, here, I create a variable year. Let's say right now, the variable year. And what is the year? 2021. So I put the 2021 in quotation marks. So this 2021 is not a number. It is a string because I've put it in quotation marks. And as you can see, it is red. 2021. I print 2021, I can print it, or I can just say 2021, I run this, but that you can see it has got quotation marks. The good practice is to print it. I can print 2021. That's what you have learned. You want to show something in a variable, you print it. So I say print the variable 2021. So print here, let me say print 2021. Okay, there. I check what type of value is in the variable year by giving the variable year to type, the function type. You use type to find out what kind of value is in year. Then we do that. Type tells me, okay, it's a string. Then I can use this function called int to change the value given to it into an integer. So this time around, if I say int here, I get this. If I get this int here, I give it to the type function. What does it do? If I give it to the type function, it tells me, oh, now I have an integer. Okay, now I have an integer. You check what is in year. What is in year has not changed. Year is still a string. You display year. That is what year is. So what I want to explain here is these functions, string, year, what they do is they make a copy of the value in the variable. When they are trying to change something, they make a copy of a value in the variable and they display that copy to you. So they don't actually change anything. What they change is the copy. So here you've got year. So here we start with year. That's year. We display the year. We check the data type of year. What kind of data is in year? It's a string. Then I get this. I give year to this function int. This function int is going to change the string year into a number without quotation marks. There, I get this. Does it actually do this? So I get this int here, I give it to type, and if I do this, type tells me the result is going to be an integer. Then if I check year again, year is still a string. So year itself did not actually change. What was changed is a copy. So when you use string, when you use int, these functions will get your variable. They will look inside the variable and say, okay, fine, there's a value here. So they will make a copy of that value. They will leave the original value alone, and then they'll modify the copy. Then they'll show you, oh, I have changed your thing into this int. I've changed into that. If you want, are we clear?
Yes, sir.
Yes. If you want to permanently change the value which is in a variable from one type to another, once this bit, we know what this does. This bit, year is a string, so we give year to int. It's going to change. It's going to display this. We have seen it. It's going to display this number. Okay? So if you want year to permanently change, then you need to store this result, which is the 2021 number. You need to store it back into the variable year. You need to store it back into the variable year. So you overwrite what was there. The string year, which was there, you remove it, then you store a new value, the 2020. Are we clear? That's what variables are for. Variables can store a value, then when you no longer need a particular value, you can remove it, then put a new value in. Is that clear? So we do that. So this is, yeah, you do that. Now you display here. Now here is a number without quotation marks. Now here has changed. You've seen? Here had quotation marks. After we do this step where we change here into an integer, then the value we store it back into here. Now it has changed, it's a number. If you ask Python what value is this, now it tells you it is an integer. Is that clear?
Yes, sir.
The other thing you can do is you can multiply strings. For example, we had this disease, pandemic thing. Actually create a variable called, I'm going to change this variable not from disease, I'm going to change it to pandemic. Pandemic, because this was not an ordinary disease. So say pandemic, then here I'll say pandemic, pandemic, then I do that. Okay, then here I also changed pandemic, pandemic, then I say print pandemic, there, it prints COVID-19. Then I can multiply this pandemic variable because it's I can multiply it by 3. This pandemic variable I can multiply it by 3. So pandemic times 3, pandemic times 3, then I get COVID-19, COVID-19, COVID-19. I can do that for a string, because pandemic, remember, pandemic is a string. Okay, I can multiply a string so many times. I can also, how do we do that? Then I can add, say, I can do something like this. Check the data type of pandemic. So pandemic, you can do that. Check the data type of pandemic. Then I add a code. I say type pandemic. Then I run this. There, it's a string. You can multiply a string by an integer, but if I try to multiply this pandemic business, a string, with a number which is not an integer, a number with a decimal point, if I try to do that with a number which is not a decimal point, then trouble starts. Python is going to come screaming. If I do this, I try to multiply by 3.5. Python will come screaming, say, you can't do this. Can't multiply a sequence by a non-int of type float. So you're only allowed to multiply, what's this? Strings with integers. Are we clear? Yes, I mean?
Yes, sir.
Are you? No, I don't. Oh, sorry. Wait. No, go outside. Okay. Any questions? Do we have any questions? All right. Hello, do we have any questions?
No, sir.
Okay. Asking user for information. So this is another important bit. So I don't know if I can do it quickly. So you can ask a user for a piece of information using the input. There's another function which I want to add, very important, before we stop, and I want to explain it quickly. Remember the way we have been working out the areas? You used to remember how we worked out the area using pi and radius?
Yes, we do.
Yes. You can actually ask a person to enter the radius themselves. So, ask person to enter the radius, enter the value of radius as follows. You can actually do that. You can ask a person to enter the radius, and I'm going to show how to do this, and that's how you're going to be asking for information from a user so that you can use that information. You're going to say input. So inside this input, you're going to say enter the radius. If I do this, I say input, enter the radius. Now see what happens on the screen. This is what happens. I get a space where I'm supposed to enter the radius. So I'm going to say, okay, fine, the last radius we had was 10, then we changed to 5.5. I'm going to say, okay, fine, the radius is 7.5. After I enter the radius 7.5, I'm going to press enter. When I press enter, immediately I press enter, the value I have entered is displayed here. Now you notice something with what has been displayed. The value I have entered is 7.5, but it has got quotation marks. Have you seen that?
Yes, sir.
Yes, it has got quotation marks. So basically what the input function does is, how do you ask for information? The piece of information you're asking for, you put it inside here. Say enter the radius inside the input function. Then it's going to show this message to the person. They need to create a box where the person is supposed to enter the information. Then the person enters that information. Whatever information they enter, whether it's a number or whatever it is, all the information is stored, is collected as a string. Whatever information is collected, it puts some quotation marks on it. So if you want to store this information in a variable, you're going to do the following. You're going to say radius, then input, enter the radius, enter the radius. You're going to do this so that whatever information input gets, that information is going to be stored in radius. When I do this, I say it says enter the radius, then I say 7.5. I press enter. After I press enter, nothing happens. The 7.5 I've entered is not displayed like this here. Okay, where did the 7.5 go? I can say print radius. If I print radius, I find the 7.5. There it is. So the information I got, I typed the 7.5 using the input function, has been stored in the variable radius. Are we clear? Then if I check the data type of radius, I say type radius, I'll see what information radius has. Radius is a string. I can't use a string for calculations. Is this bit clear? Where we get information from radius, from input, and we store it in radius, then we print it out. Hello? Is it clear?
Yes, sir.
Okay, so we can't, now, the radius is a string, so we can't use it for calculations. The thing we have to do is we need to change radius into a number. And how are we going to do that? We're going to say radius is equals to, now there's this other function called float, then you put radius there. This radius, this float function is going to change the radius from a string into a number which has got a decimal point. Now if I print radius, radius, print radius, that's what I get. If I ask for the type of radius now, now radius should have changed into something we can use for calculation, a float. Now remember, our area was equals to, say, pi times radius to the power 2. There. So we can work out the area, then after that we can print the area. So right now we have figured out a way of creating a piece of program which gets information from someone, then it works out the area. So here, the first bit is we get the radius. Here, we get the radius. After getting the radius, so here I do the following. So I put a comment, say, ask the user for a radius. So the user is going to enter the radius and store it and store it and store it. So we're going to ask for user for a radius, then you store it. Next, we are going to convert the radius, get this radius, we're going to change it into a number. Okay? Convert the radius into a float. So we are changing the radius because we know when you get something from anywhere using input, that thing we are getting is a string. But because we want to do a calculation, we cannot use a string. So after we convert, then we can say calculate the area. You can calculate the area. And how do we calculate the area? By using this. Calculate the area. Then after calculating the area, we can say print the area. So we say print. You can say the area is, then we say area. Yeah. So now we can, this which we have here, what we have done here with all these variables, now we are using everything we have learned. We have used everything we have learned now. How to comment, then how to ask for information. This one here is a string, then that's a variable. Then we how to change this radius, which is a string, into a number. Then how to carry out calculations with variables. Then how to print. This right here is a complete computer program which works out the area of a circle. So if you run this now, we run that, it's going to ask us enter the radius. We enter the radius. Now the radius is 15. Then after that, it's going to work out the area is that. Are we clear?
Yes, sir. Okay.
Yes. So in one lesson, we have actually created a working program which works out the area of a circle. With everything we have talked about, the comments, the variable, the input function, the string, then changing radius from a string into a number, then doing calculations with variables. We're doing multiplication here. We are raising radius to the power. Then we print out two values. We print out the string, we print out a number, and this is what we get. So this is what the future looks like. You being able to talk to your computer and telling the computer exactly what you want it to do for you. And this, yes, you can do this by hand or you can do this with a calculator, but what we want in this course is for us to be able to carry out calculations, physics calculations or engineering calculations using a computer. We tell a computer, do this, we give the computer instructions and the computer carries out these instructions because computers are much faster than we are. We can never match computers when it comes to fastness and also accuracy. So we have to start using these things. Are we clear? And any questions?
Yes, sir.
Any questions? Do you have any questions? So far with what we have learned today and what we have accomplished?
No.
Mwape? Okay, so if you have got no questions, we come to the
Well,
end.
getting you.
Huh?
That's what.
Ati?
Me, I'm using yeah, I want to find out something. I'm using Anaconda here.
No. We don't want you to use Anaconda right now because we're going to do the Anaconda business when we meet in person.
It opens.
Yes, what I want you to use now is Google Colab, because for Google Colab everything is there, and as you can see, as I've been doing things, it's straightforward. There are only two places where you have to press, and how to edit, I've shown how to do that. Okay? Yes, so I want you to use Google Colab for now so that we can make progress, we can learn how to use this language, how things work. Then once we learn, when you guys come back into campus, then we can look at the Anaconda thing, because the Google Colab requires an internet connection, but the Anaconda business can work without an internet connection. Are we clear?
All right.
Yes, so the reason why I've chosen Google Colab is because you just go into Google search, Google Colab, then you click on it, then it opens up, you say, okay, fine, this, then things start. So we'll talk about the Anaconda business and how to use it the same way we talked about Google Colab and how to use Google Colab when we meet in person, because we have got two computer labs full of computers. So if you don't have a computer or your computer is not fast enough, we'll give you a computer. Just a minute. Any other question? All right, so if there are no questions, let's end here. Thank you very much for your active participation. That's what we want. We want you to participate, ask questions where you don't understand. I understand this is a lot of new information. Please find time during the weekend to rewatch the video and also to go through the same thing, the PDF and the stuff. I'm going to upload a PDF, make a PDF of this same thing, so you can print out the PDF, have a look, then also you can play the same notebook in your Colab over the course of the weekend. Watch the video so that you understand, because there is more information which is going to come. All right, we are done today. I'll stop sharing.
All right.
Okay, so see you on Monday? Is it? Yeah, see you on Monday, I think. Okay.
Yes, you're trying to reach me at one time, huh?